the problem that I'm going to solve now is problem number 6, which is where we have to graph the function. We actually have to go through the whole process, find all the elements in order to sketch, right? We're going to sketch this graph. Well, but in order to do it, we're going to follow the 7 steps. That's why I told you to take this, grab these 2 forms in order to go through the steps and obtain the graph easier. So the first step is going to be, the equation is 4x plus 1, f of x is number 6, f of x equals to 4x plus 1 over x minus 3. Okay, so let's start with problem number 1. We're going to factor and cancel. Well, if you notice it, in this problem, there's nothing to factor top and bottom. So, we're going to start right away. There is no holes in this problem. There's nothing to factor. We don't have any holes. Problem number 2 is find the vertical asymptotes. I'm following these steps right here. Number 1, you do all the work you have to do there. And then in case you don't have any common factor to cancel, you're gonna say in this function we don't have to cancel anything, and therefore there's no holes. Problem number 2, find the vertical asymptotes. So step 1, no holes. Step 2, it says find the vertical asymptotes. We know from the notes that you already have with you that in order to find the vertical asymptote, we set the denominator to 0. So it's going to do this in the second little rectangle. So with x minus 3 equals 0, add 3 in both parts. X equals to 3 is the vertical asymptote. So what you have to do here in this case is start graphing. You know, once you're following the steps, you can start graphing. And I have this specific, this is going to help us to graph. The first element, which is x equals to 3, is a vertical asymptote. So we have 1, 2, 3. I'm going to just draw a dotted line here, which is a vertical asymptote. X equals 3, vertical asymptote. Okay? What else? I'm going to put it one side here. We're going to go back to this one right now. For step number 3, find the horizontal asymptotes. Vertical asymptotes. Step 3. Horizontal asymptote. To find the horizontal asymptotes, remember we compare degrees. Compare degrees. We have 4x, f of x equals to 4x plus 1 over x minus 3. The degree of this one is this exponent, n equals 1. The degree of this one is m equals 1. Since n is equals to m, what happens is that you have to divide the leading coefficients. Y equals to 4 over 1, which is 4. Y equals 4 is the horizontal asymptote. So, come back to this one. Y equals 4. 1, 2, 3, 4. This is a horizontal asymptote. 1, 2, 3, 4, right here. So I'm going to do this. Horizontal asymptote is y equals 3. See? That's what we have so far. The next one, step number 4, find the x and y intercepts. X, y intercepts. So x-intercept, for x-intercept we go with the numerator. Numerator equals to 0. In this case it's 4x plus 1 equals to 0. Subtract 1. 4x equals to negative 1. Divide by 4. x equals negative 1/2, negative 1/4 is the x-intercept. So x equals to negative 1/4 is going to be the x-intercept. So let's see, x equals to negative 1/4. This is negative 1/2, negative 1/4, let's say, is right there. Y-intercept is going to be f of 0, 4 times 0 plus 1 over 0 minus 3. This is the same as negative 1 over 3. I found another intercept, which is negative 1/3. If it's negative 1, negative 1/3 is going to be somewhere there. Okay. This is an asymptote, so you can see right away this is going to be like this. Okay. Continue with step number 4. Sorry, 5. Is find domain and range. For the domain, it's gonna be easy for you guys because domain, these two little squares are gonna help next to each other. Whatever you did here, you have to do it here. So use the answer from this one to answer this one. To find the domain is all real numbers except the value where you have x in the vertical asymptote. So x domain is going to be all reals except x equals to 3. In range, all reals except y when you have the horizontal asymptote. Y is 4. So that's step number 5. Step number 6, create 2 tables. We're ready to create the 2 tables. Since we have in our table, in our graph, we have x equals 3 is a vertical asymptote, I need 3 values before the 3 and 3 values after the 3. So I'm going to select these values, 0, 1, and 3. And after 3, 4, 5, and 6. In your calculator, you're going to turn it on. Then we're going to go to Y. Let me erase to clear all this that I don't need. And I have Y equals to parentheses 4x plus 1. Close the parentheses, divided by x minus 3. There you go. You see this? Then we're going to window. I'm going to start with zoom 6, which is going to give me the standard window, and let's see what happens. I want to see a little more to the right because this part of the graph is up here. I don't see it very clearly, so I'm gonna go with to my window and open a little bit more my x to 20 and going by 2's, and then the maximum for y also 20 going by 2's, and let's see what happens. See the graph, and now it's going to be a little bit more clear. See? Okay. You can also, don't forget, you can also graph the horizontal asymptote, which in this case we said is, horizontal asymptote was y equals 4. So I can see the horizontal asymptote doing this. Okay. We set 3 values to the left of the vertical asymptote, which is 3. I am going to start with going to second table. And I need to delete all this stuff because I'm not using it. Okay, I'm gonna start with 0, enter, 1, enter, oops, sorry. Second table set, I need ask and auto. Ask and auto for dependent variable. Second table, I'm ready to start, 0, enter, 1, and 2. And if I put 4, I understand. If I put 3 here, I know it's gonna give me an error because it's right there. You have the vertical asymptote. 4, 5, and 6 are the other ones. You have to just graph these points and connect them following the form of the hyperbola. Let's see. 0, negative 1/3. We already had it there because it actually coincides with the y-intercept. 1, 2.5. 1, 2.5 is going to be, no, sorry, 1, negative 2.5. 1, 2.5. 3, 2, negative 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see the parabola the hyperbola is going this way. So I can start sketching the graph, just going like this. Oops, sorry, you have to go through the points and keeps getting closer and closer to the asymptote. So very horizontal and vertical. To the right, to the vertical asymptote, we have 4, 5, and 6. For 4, 17. That's gonna be 4, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is number 10, so 17 will be all up there. We don't see it. Okay. 10.5. 5, 10.5. So 4, 5, and 10.5 is going to be somewhere here. And the other one is 6, 8.3. 4, 5, 6. 8.3 is going to be 8.3 somewhere there. So connect the points, knowing this is the asymptote, this is the other asymptote, so it's going this way. And then don't forget, you can just compare, and you're gonna see that it's very similar, and that's it. Then you have to copy the tables in this spot, and the graph, sketch it in that part.